Hi everyone, welcome back. In this video, what we're going to do is we'll start talking about Newman projections. So Newman projection, this is one type of representation of organic compounds, and this is mostly applied to alkanes. Although you could do a Newman projection on other classes of organic compounds like alkenes or alkynes, it is most useful for alkanes. Okay, so we will use this mainly for alkanes in chapter 4. Okay, now what is this representation? So I will first help you, at least walk you through the process, how do we draw it, and then we'll look at a few examples. So let's start with the simplest alkene, but 2-carbon alkane that's possible, okay? So we'll start with ethane, so C2H6, okay? This is CH3 and CH3, okay? Now, to start drawing a Newman projection, we need some three-dimensional information. We cannot do it on a condensed or structural formula like this. Okay, we need a Lewis structure. If not complete Lewis structure, we need a bond line structure with some three-dimensional information given to us. So let's say for this ethane molecule, I'm going to say that we have 2 carbons, and then we have the 3 hydrogens on that carbon, and then we have 3 hydrogens on this carbon. Okay. Now this structure, it actually gives me some three-dimensional information, okay, in terms of orientation and space. Because when I look at the structure, what I see is that we have 2 carbon atoms, okay, and this hydrogen and that hydrogen, which are on a wedge, okay, on wedge bonds, these are pointing outside. They are coming outside the plane of the whiteboard. So this hydrogen is somewhere here, outside the plane of the whiteboard. This hydrogen is pointing down, but here, outside the plane of the whiteboard. That hydrogen, okay, is behind the plane of the whiteboard, so it's somewhere behind, but it's also pointing up. This hydrogen is behind, but now pointing down, and these 2 hydrogens are in the plane of the whiteboard. So in this particular representation here, I have 4 atoms which are in the plane of the whiteboard, and those would be hydrogen, carbon, carbon, and the hydrogen. They are all in the plane of the whiteboard because they are connected using straight line bonds. Okay, so there's some three-dimensional information here. Now, to draw a Newman projection, okay, for this molecule, and actually even before we go draw it, Newman projections are drawn about a carbon-carbon bond, okay? So you're drawing a representation about a carbon-carbon bond. In this particular case, there's only one carbon-carbon bond, okay? So that is this bond here between the 2 carbon atoms. So that is the only bond about which I can, well, it does not have to be a carbon-carbon bond, actually, so don't get me wrong there. Let's just say it is about a bond, okay? Some bond, some XY bond, okay? It has to be about a bond that we draw a Newman projection, okay? I think that's more correct of a statement, but for our purposes, again, we'll be drawing it across, or we'll be drawing it about carbon-carbon bonds. That's something to remember. Okay, so for this particular molecule, if I have to draw the Newman projection, what I'm going to do is I'm going to look at the carbon-carbon bond such that I'm actually looking at one of the carbon atoms, okay? So for this particular molecule, let's say if I'm looking at the molecule from here, okay, from this side on the board, and I'm looking on that carbon. And so what that means is my eye is somewhere here. That is how I am looking at that molecule. My eye is here. Okay. Now, when I look at the molecule straight down, okay, I'm looking at the first carbon. So let's call this the front carbon. And the other one is the back carbon. Okay. The other one is the back carbon. The second carbon in the bond that I'm looking at, that is the back carbon. So the front carbon in a Newman projection is represented by a dot. Okay, that a dot represents the front carbon. So when I look at it from here, okay, I see the front carbon. Okay, I'm looking at the molecule from there. So I see the front carbon. That front carbon I'm going to represent by a dot. That's it. Okay, there's nothing else. So this here is the front carbon. Okay, and I will label it later. Okay, now when I look at it in that direction, notice how this hydrogen, and maybe we can label these hydrogens as H1, 2, 3, 4, 5, and 6. Okay, notice how H1 is in the plane of the whiteboard pointing up. That's where it is if I look at it from here. So I am looking at the molecule from here. And so you have to sort of visualize this, okay? So I'm looking at the molecule from here. And what I notice is H1 is pointing up in the plane of the whiteboard. So I'm going to draw whatever I see when I look at that carbon. So when I look at this carbon from here, what I see is that carbon is a dot and H1 is pointing up in the plane of the whiteboard. Okay. H2, where is H2? H2 is a hydrogen that's sticking out. Okay. It is coming out of the plane of the whiteboard like that, like in this direction. So when I look from here, where is H2? I'm like in the plane of the whiteboard. When I look at it, H2 is coming out. That means it is on my right side, essentially, when I look at it. Okay, so, and it is like pointing down. It's like going down a little bit to the right. So I'm going to draw what I see. I've got H2 over there. H3 is pointing down, but it is inside the plane of the whiteboard, so it's going back there. That means it's on my left now when I look at it from here. Again, looking from here, H3 is on my left, so I'm going to draw H3 on the left. And I've drawn all the substituents, the three hydrogens, not the substituents, the three hydrogens on carbon 1, the front carbon, okay? That's our front carbon. This dot here, okay. The back carbon is represented by a circle, okay. It is represented by a circle. So the back carbon is behind the front carbon, okay. And so what we do is, since this is the front carbon, I'm going to draw the back carbon as a circle here. Okay, that circle represents the back carbon. Okay, now let me go ahead and include some labels here. So we'll say that, sorry, say that this here is the front carbon, and I'm going to say that the circle here is the back carbon. Okay, so we have the front carbon and the back carbon. Now I'm done with the front carbon. I'm looking at the back carbon again from the same direction, from here, about that carbon-carbon bond. So I'm looking straight down at that back carbon. So when I look at that back carbon, what I notice is H4 is pointing down. Now it is slightly angled, but I do not know that looking from here. Okay, so the H4 is pointing down from that back carbon. Okay, so it's connected to the back carbon and it is pointing down in the plane of this whiteboard. So what I do is from this back carbon, I'm going to draw H4 pointing down. Okay, H5 is pointing up, and since I'm looking at it from here, H5 is to my right hand side. And so I'm going to draw what I see again. I have H5 here, and H6 is behind the plane of the whiteboard. So when I look at it from here, it's on my left. So I draw H6 pointing up over there. And basically, I've finished my Newman projection. Okay, so this three-dimensional molecule, or this three-dimensional picture, has now been captured into 2 dimensions. Okay, and we've drawn a Newman projection, but this 2-dimensional picture gives us 3-dimensional information. Okay, that is the key here. Now, if I were to look, I chose to look at this molecule from the left-hand side. If I were to look at the molecule from the right-hand side, okay, what would this look like? So let me erase some of this, and I will draw what this molecule would look like if I had drawn it from that end. Okay, if I looked at it from the right-hand side, and then I drew the molecule, I think I'm going to see something very similar. Well, not exactly, but there will be some similarities there. So now if I look at it from here, okay, the back carbon here, okay, in the first case, that would become my front carbon. So I'm going to represent that by a dot, okay. And when I look at it from there, okay, I have H4, which is in the plane of the whiteboard, and it's pointing down. So I'm going to draw H4 pointing down. And since I'm looking from here now, H5 is coming outside the plane of the whiteboard here. That is now on my left-hand side, okay? So when I look at it from here, I'm going to draw H5 on my left. Similarly, H6, which is behind the plane of the whiteboard, is on my right-hand side. So I'm going to draw H6 over there. And then from there, the front carbon here is connected to the back carbon. That back carbon would be represented by a circle. Okay, the circle represents the back carbon. Okay, and on the back carbon now, we have H1 that is pointing up. So I see H1 straight up. So I will draw H1 pointing up. And I have H2, which is a wedge coming out to my left. Okay, so I draw H2 down here now, and H3 on a dash bond, so it is to my right, so I can draw H3 here. So if you notice, there are some similarities, okay? And that Newman projection is basically this Newman projection flipped over in some sense, okay? If I take this and flip it over, notice how H6 and H3 would be on that side, H5 and H2 would come here on this side, and then H1 and H4 would remain at the same position. So that Newman projection is this Newman projection flipped over because we looked at it from the opposite end, okay? So that is how you draw Newman projections. Let's go ahead, look at a few examples, okay? Maybe one or two examples just to make sure that we are able to do this, okay? So let's look at an example here where we have, I'm going to pick something from the textbook. So let's say we have fluorine and chlorine, okay? That's the molecule that we have. Now, when I look at this molecule, I notice that there are some bonds missing because not every bond is shown, like the entire 3D, but those are just implied in this bond line structure. For example, at this carbon here, and I'm drawing a Newman projection about this bond, okay? That's the direction that I'm looking at along this bond. This is the bond that I'm considering about the carbon-carbon bond here. Okay, it's always about a bond. Okay, so what I notice is on this front carbon, there's clearly an atom missing or a group missing. Something is not shown, which is the dash here. You could add it in for a start, but I think like slowly we would want to get over it, okay? And then just be able to do it without drawing it in. So there is a hydrogen missing here because I don't see what's on the dash here unless I add the hydrogen. Similarly, on this back carbon, there isn't anything on the dash. Why is it that? Because there is a hydrogen here as well. That hydrogen is on the dash. Okay, so now that we have this, and I'm looking at it from this direction, okay, from the left, okay, that's how I'm looking at it. So the Newman projection for this molecule, so when I look at it, I see the front carbon, okay, and in the plane of the whiteboard, when I look at it, pointing up, I see a methyl group. So there it is. Okay, that's a methyl group. I don't have to write it. Or if you want to, you could write a CH3, but you do not have to. You just leave it there, and that is CH3. Okay. And again, when I look at it from here, on the wedge pointing down is a chlorine. Okay, that chlorine is on a wedge pointing down, which means to my right-hand side. So I draw what I see. I draw the chlorine pointing down. The hydrogen is to my left, pointing down. And I'm done with that front carbon. Moving on to the back carbon. The back carbon would be again represented by a circle. Okay, that back carbon is a circle. And on the back carbon, we have a methyl group that is pointing down. Okay, that is pointing down. So we have a methyl group here pointing down in the plane of the whiteboard. Because it's in the plane of the whiteboard, I'm drawing it straight down. The chlorine is on a wedge pointing out to the right. So I draw the chlorine pointing out to the right. The hydrogen is on a dash pointing to my left. So I draw it to the left. So that would be my Newman projection for this particular molecule. Now, notice something important to keep in mind is the groups that are connected to the back carbon, they start from that circle, okay, from the perimeter of that circle essentially, okay, because that represents our second carbon. They do not start from this point in the middle because this is our first carbon, okay? And so when we look at it, the way we understand this is, the front carbon has 3 bonds to it shown. The 4th bond is actually to the circle, which is the second carbon, okay, the carbon behind it. And they are both connected to each other, okay? Let's try to draw another one. Well, let's try to work like another one out here. Okay, so let's say if we have something like that, and now we're looking from that direction. Okay, we're looking from that direction. That's where the eye is. Now, you do not have to show the eye. Just an arrow is fine. I'm just drawing it in to say that you're looking at from that direction down this bond. So this is the bond that you're looking at. Okay. So when I look at that from that direction, from that carbon, this is my front carbon. Okay. That's the front carbon. This here is the back carbon. Notice how on the back carbon, there are no groups shown here. That means there are two hydrogens here, one on a wedge and the other one on a dash. Because to any carbon, you draw two straight lines and then one wedge and one dash. We went over this in chapter 1. So if you want a refresher, please go to like chapter 1 videos. And we did go over this over there. Representations, and we talked about representations. Okay, so we have our front carbon looking from there. And on the front carbon, there is a methyl that's pointing down. So I draw a methyl pointing down, CH3. And the chlorine is on a wedge coming out, and there is a chlorine on the dash going in. So that means there are chlorines onto the left and to the right when I'm looking from there. Okay? So chlorine and chlorine. Back carbon is a circle. Okay, the back carbon is a circle, and on the back carbon there is a methyl group pointing up. So we can draw a methyl group pointing up on the back carbon. And similarly on the back carbon, there are two hydrogens, one on a wedge, one on a dash. That means one's on our left, one's on the right. So we will basically draw those in. So that way we've completed our Newman projection. Okay, so those would be Newman projections for the molecules and looking at them in a particular direction. Now, sometimes the direction may be specified and other times the direction may not be specified, which means you can look at it from either direction. And then going back to our previous example, like the ethane that we work with, realize that when you look at it from both directions, the Newman projection is just going to be flipped over, okay? So that's an introduction to Newman projections, how they are drawn. In the subsequent lectures, we will use Newman projections to do some analysis on alkanes, okay? I hope that is useful. Bye.